share my slides. Perfect. All right, so good morning, everyone, and thank you for joining us. My name is Cassandra Sani, and I help lead the Inland Regional Energy Networks, or IREN's Codes and Standards Training Program. This is not in present mode. Let me fix that real quick. There we go. Yes, so I'd like to welcome you all to this webinar on behalf of IREN. We're really excited to announce that this training is being simulcast in Spanish. If you'd like to hear the Spanish audio, simply click on the interpretation icon, which should look like a globe, and select Spanish under Listen In. So again, you should have something that looks like a little globe, and then just be able to click it and click the Spanish audio selection. The Coachella Valley Association of Governments, the San Bernardino Council of Governments, and the Western Riverside Council of Governments have partnered to develop IREN to serve the cities and communities of our region. Together, IREN represents 2 counties, 52 cities, 17 tribes, 78 unincorporated county areas, and 11% of the population of California. IREN connects the workforce industry, local governments, and other stakeholders to a wide range of energy efficiency resources. Our aim is to provide equitable access to all benefits of energy efficiency, including cost savings, to those who live in Riverside and San Bernardino counties. This presentation is part of IREN's Codes and Standards program. We work closely with local building departments and the building industry to support, train, and enable long-term streamlining of energy code compliance. IREN implements a dynamic and targeted set of programs to assist local government agencies in better understanding and enforcing the energy code. Our next 2025 Code Series training is on Thursday, September 25th, where we will be discussing non-residential energy code updates. On October 23rd, we'll delve into 2025 code updates for Cal Green. Watch your email inbox for more details on these programs, or you can always email info@iren.gov for more information. I'd also just like to highlight for any architects in the room, we're partnering with the Inland and Desert AIA chapters to host a series of trainings on zero net carbon design. These will take place on September 17th and 18th, and more information can be found on iren.gov. Finally, before we get into the meat of today's discussion, I'd like to hand the mic over to Grant Murphy to introduce himself and IREN's Energy Code Support Program. Grant?
Thanks. Hi, everyone. My name is Grant Murphy. I'm with Imbalance Green Consulting. We're a subcontractor providing codes and standards training and support for IREN. So you might have seen one of us doing these presentations at other times. The quick pitch I want to share is in regard to the Energy Code Support Hotline, which supports Title 24 Part 6, the Energy Code, and Part 11, the Green Code. I believe we have a next slide. Yeah, energy code, green code. I think the next one is the hotline. Okay. So there's a web form, which I think shows up on one of the slides that you fill out, available on the IREN site. There'll be a link in the presentation, which will ask a few questions about yourself, your project, your question related to Part 6 or Part 11. That web form submission directly hits my inbox, so myself or Jennifer Rennick will get back to you quickly with a response to help resolve whatever you have. The service is free. It's funded by IREN, and it's free for anyone within the IREN region to use, private and public sector alike. So any building department staff, architects, designers, builders, homeowners working on your own project, anybody. So a few example questions we threw out here just to get you guys' brains thinking. A common one we get is I'm being told I need energy forms. What are those? We're happy to help walk you through what forms are applicable to your project. What's the code require for an unvented attic? What are the panel requirements for meeting the ESS battery code? No questions too simple or complicated. So, our ask today is just to share this link with your colleagues or customers and help spread the word of this program's existence. Thanks for everyone for the time.
All right, and thank you, Grant. We've been hearing that a few folks have had issues with the Spanish audio. So if you go to your bar, where it should say participants, chat, raise hand, share, there should be a little globe that says interpretation. If you click the globe, it should say listen in, original audio.
Maria, I can hear you, but Cassie can't hear you. So that. Oh,
Kate disappeared.
Maria, hang on 1 minute. Cassie, can you hear Maria?
No.
I can hear Maria. So that means we're both in the room.
Okay.
Maria, feel free to continue with the translation. I think we're good to go. Okay.
All right. Yeah, so
Okay,
for any
I
folks
see.
who want to
Thank you.
listen in Spanish, just click that globe and you should have the option. It should say listen in, English or Spanish, and you should be able to click that. Brian, do you want to go ahead and start sharing your slides while I introduce you?
Absolutely.
Awesome. So today's class will summarize the new and revised requirements in the 2025 California Building Energy Efficiency Standards for Title 24, Part 6 for multifamily buildings and direct participants to informational resources and training that provide more in-depth information on the energy code. We're really excited to welcome today's trainer, Brian Selby, a principal at Selby Energy Incorporated, where his primary role is developing and delivering comprehensive energy code training for Energy Code ACE's Title 24 Essentials courses. He has over 35 years of experience as an energy consultant and is an energy code subject matter expert and interacts with the California Energy Commission, investor-owned utilities, association professionals, and other industry stakeholders to foster education, promotion, and compliance with the California Building Energy Efficiency Standards. He is very committed to helping this industry learn and adapt to the ever-changing requirements of the Energy Code. We'll have time for questions for our presenter, so please put them in the chat box.
Awesome.
Floor
Well,
is
thank
yours,
you.
Brian.
Thank you, Katie. Appreciate the opportunity, and thank you to Iron for this opportunity to share our code breaker on the 2025 multifamily update overview. We do have a lot of information today, so I will be moving at a fairly quick pace to get through the information within our timeline. But I do encourage you to ask questions. If there's a question that you have regarding a certain requirement or a change in the code, please put that in the chat window. Happy to address those as we go through the presentation. Our objectives today is really to identify those areas of change from the 2022 code to the 2025 code. There are new requirements and there are some of the existing requirements that have been updated to be more stringent. So we'll go over these in a bit of detail here. Now, this is focused primarily on multifamily buildings. So if you have questions for other building types, single family or non-residential, we do have courses available to address those specifically. So before we get into the presentation, we do have a shameless plug from our sponsor, Energy Code ACE. So if you haven't been to the Energy Code ACE website in a while, you'll notice that we have new tools available, new training and new resources. All of these have been updated for the 2025 code. We're still in the process of updating some of those. For example, if you're used to using the reference ACE, it's an online version of the energy code, the appendices, the compliance manuals, and the ASEM reference manuals. We're in the process of updating that for 2025. So you can use the 2025 reference ACE just understand that it doesn't have all of those elements yet. It just has the administrative code and the energy code. So we're in the process of updating everything across the board here. So go to the website, check out our tools, our training, and our resources. They're here to help you increase compliance with the energy code and answer some of your questions. So, all right, without further ado, we'll jump into our course material. Through all of the Energy Code ACE courses, we like to provide these handy icons, these course conventions, typically in the upper right-hand corner of the slides. It just helps you understand what type of requirement that we're talking about. For example, a mandatory requirement. Mandatory means mandatory. They're not optional requirements. And if that requirement applies to your project, that must be met. You can always exceed mandatory requirements. You just can't trade them away. But keep in mind, there are exceptions to a lot of these requirements. Moving to the prescriptive icon, that RX symbol, typically in the upper right-hand corner, it's going to identify whether the prescriptive requirements apply. And we'll talk a little bit more detail about what prescriptive versus performance means, but just understand that these are requirements that apply based on the project type and the location or climate zone the project is in. Moving over to the performance approach, this gives the compliance flexibility, meaning that we can use a computer software program to simulate the building's energy efficiency over the course of a year and compare that to a baseline, which by and large is going to be those prescriptive requirements. And for a project to comply with the performance approach, you would need to demonstrate that it uses as much or less energy than the baseline. So we'll talk about this a little bit more in detail. If you have questions, please let me know, and happy to elaborate a little bit more. So we're going to take a look at some of the overall scope changes in our code here. So if you weren't aware, January 1, 2026, the 2025 code cycle will go into effect. That means any project that is submitted on or after that date will be subject to meeting those requirements. Projects submitted up till the end of 2025 will be subject to the 2022 code. So if you haven't already downloaded a copy of the standards, manuals, appendices, and so forth, you can go to the Energy Commission's website and download those, as well as you can go to the Energy Code ACE website and use the reference ACE to access those documents as well. All right, some minor changes in our the building types or occupancy types that are covered or regulated by our Title 24 Part 6 Energy Code. You'll see here a new occupancy type L, or laboratories, are now regulated under our energy code, along with the other occupancy types. We've thrown in a few helpful hints here, these arrows down here for the residential or R occupancy, just to help you understand how these occupancies or how the energy code applies to these individual occupancies. You'll see that R2 specifically uses the multifamily portion of the code. This applies to apartment buildings, dormitories, multi-user residence, mixed-use buildings, any dwelling, any single or residential dwelling that has more than 2 dwelling units would be subject to the multifamily portion of the code. So, in addition to the added occupancy type, the energy code has changed the compliance metrics. Once again, title of the slide is Evolving Building Energy Efficiency Ratings. So currently under the 2022 code and previous code cycles, we use the metric of time-dependent valuation to evaluate the energy usage of buildings. Time-dependent valuation is a really unique metric, meaning that it takes into consideration the type of fuel being used, the general location in which that building is located, and the time of day and the time of year that specific end uses end-use energy is being used, such as electric energy, natural gas, or propane. Time-dependent valuation looks at the cost of that energy used during those time periods and obviously puts a higher value on energy when it is in its most demand. For example, electric energy use during the summertime in a hot climate zone. There's a considerable amount of electric energy use for air conditioning. Therefore, that type of energy, the location and the time of day and year that it's being used is of the utmost priority. So this metric has been used for years, decades in our energy code to determine how a building's energy is being used. Now, moving into the 2025 code, the Energy Commission has decided to change this metric from time-dependent valuation to long-term system cost. So the advantage here is not only is it also doing the same job as time-dependent valuation, it's looking at the value or the cost of energy to California's energy system over that period of 30 years. So it's looking further down the road to ensure that we have energy sources that are readily available and accessible for everyone for our building energy use. So these metrics take the same form as they did under the 2022 code. Rather than time-dependent valuation efficiency, we have LSC efficiency. That we'll go into that, what that represents here in a minute. We also have a total LSC. That's the building's efficiency after factoring in our solar PV and other flexibility measures. The source energy, that is a proxy for carbon emissions. So whether there's fossil fuel appliances on site or there's carbon emissions associated with the generation of that electricity is where that metric captures the overall carbon emissions for a specific building. So the LSC compliance metrics, we'll dive a little bit deeper in here. So that efficiency LSC, this score represents the building's overall efficiency in terms of long-term system cost. So this includes features in the building, common features, all of the envelope. That means our walls, floors, ceilings, windows, doors, the efficiency of that envelope. Any fans, blower fans, such as indoor air quality fans, HVAC system efficiency and energy use, domestic hot water, and other loads that are associated with that building's energy use, such as plug loads, lighting loads, other interior loads that are associated with that building, all come together to assess the building's annual efficiency. Moving to the middle bucket, total LSC, as I mentioned earlier, this score represents the total LSC of the building after factoring in the PV and flexibility requirements. We all know what solar PV is, right? On-site electric power generation. The flexibility measures are features such as battery storage systems or the strategy to pre-cool a space leading into those peak price tariffs, typically in the late afternoon to early evening during the summer months and fall months. So those strategies can be used to lower the total LSC. Moving over to the source energy, this score represents the building's energy efficiency in terms of hourly source carbon-based metric. So takes into consideration all of the same features and systems within our building, including the on-site power generation and energy storage, and it determines what the overall score for carbon emissions. Now, for a building, a multifamily building to comply under the 2025 code, a new construction building would need to meet all three of these metrics, meaning that the proposed design, the features that are being used for the building, that those scores for each of these three metrics needs to be equal to or less than the standard design. So this means that all three must comply. If one of these metrics fail, the entire building fails, and it would need to be improved in order to demonstrate that it meets the all three compliance margins. Here's an example of the results of a CBEC model. So CBEC is the Energy Commission's performance-based software that is used to demonstrate compliance for multifamily buildings, as well as non-residential and hotel-motel buildings. So you can see these metric scores over on the right-hand side. Total LSCE, that's the efficiency. LSCT, that's our total LSC, and our source. Now you can see here one of those metrics does not comply, the efficiency LSC. That means that the proposed efficiency LSC score is greater than the standard design. And for this project to comply, they would need to consider improving their overall efficiency of the building so that all three of these metrics complied. All right, we do jump around a little bit in these courses because we're just covering the substantial changes in the energy code. So apologize for some of the abrupt changes from one topic to another. We're moving into refrigerants, and the refrigeration process. So you can see here the California Air Resources Board, or CARB, has come out with new requirements for our refrigerants. Specifically refrigerants with a low global warming potential, or GWP. These are regulated at the manufacturer's level, so products that come pre-charged with refrigerants must use these lower GWP refrigerants. Now, keep in mind, whenever you're dealing with these newer refrigerants, some of the refrigerants have become more flammable. So when we're dealing with multifamily buildings, there should be some considerations made for how that refrigerant is getting from the condensing unit that is typically on a rooftop or other locations to the individual spaces where the air handling equipment is. So need to be aware of that in the design phase so that you meet not only the energy code requirements, but also other requirements that might be regulating where these refrigerants can go within the building. All right, quick check your understanding quiz. You're welcome to type your answers in the chat window here. I'll read the questions. You can put your answer in the chat. So question number 1, which energy efficiency rating is used to evaluate multifamily building performance under the 2025 Energy Code? Would that be EDR, or Energy Design Rating, LSE, Long-Term System Cost, TDV, Time Dependent Valuation, or LCC, Life Cycle Costs? I see David has responded. Mitchell responded with B. I think you folks are listening in, so that's great news. If you said B, you're absolutely right. So the metric moving forward with all building projects using the performance approach will be using the metric long-term system costs. Great. All right, let's move on to some of the mandatory requirements. What have changed from the 2022 code, or there are a few new requirements here as well. So a couple things I like to discuss first are defining the spaces within a multifamily building. Now these space terms were introduced in the 2022 code. And the reason for that is that certain requirements for high-rise residential buildings that were in the chapters associated with non-residential and hotel-motel buildings, as well as the low-rise multifamily buildings that were associated with single-family or low-rise buildings. Both of those categories were moved to their own subchapters within the Energy Code. So we 2022 code introduced 3 brand new subchapters, all specifically there for multifamily buildings. Now, because of that, and because of the change in which compliance software could be used to demonstrate compliance using the performance approach for multifamily buildings, new terms had to be introduced. So when we're talking about multifamily buildings, we're talking about two primary space types. We're talking about the dwelling unit. That's where people live, sleep, eat, cook, and use those spaces to facilitate for one or more persons. Now, we also have common use areas within our buildings. These act and feel like non-residential spaces. In fact, in many cases, the requirements for these are the same as our non-residential buildings, but these are our occupancies. That's hard to say. These are our occupancies within a multifamily building, and they are subject to the requirements of a multifamily building. Those include, but not limited to, corridors, community rooms, laundry rooms, other spaces such as offices that are there to support the dwelling unit. Now, the common use area does not include any of those spaces associated with a non-residential occupancy. That would make the building a mixed use. So we have, in some cases, non-residential occupancies that have no association with that multifamily building, and common use areas that are associated with multifamily building to support the residences within those dwelling units. So keep those separated just so that it makes everyone's life a little bit easier. All right, now that we have that understanding about the different types of spaces within a multifamily building, we have some new mandatory requirements for wall insulation. Now, these apply to above grade walls. And we're talking about exterior walls or demising walls. Exterior walls obviously are separating the condition from the outdoors, the ambient air. A demising wall would separate an indoor condition from an indoor unconditioned. So in these situations, the minimum mandatory requirement for 2x4 wood framed walls is to achieve a overall U factor of 0.095. That has been reduced from the previous code cycle of 0.102. And 2x6 walls achieve an overall U factor assembly of 0.069. Now, these can be interchangeable, either meet the overall U factor for the wall or meet the nominal R value of cavity insulation within that wall. Now, you can also see that the stringency increased for the nominal R value, going from an R13 to an R15 in a 2x4 wall, and R20 to an R21 in a 2x6 wall. So not a major shift in our energy code, but these have been increased stringency. All right. Other mandatory requirements here. This is regarding the dwelling unit mechanical ventilation, otherwise known as indoor air quality. Now, I'm going to be talking about prescriptive requirements, so make sure you understand that mandatory requirements must always be met. Prescriptive requirements can be traded off using the performance approach. And many times those requirements are different. So for new construction, all dwelling units in a multifamily building must use the same ventilation strategy, meaning that you can't have one dwelling unit using a supply ventilation strategy and another dwelling unit using a balanced ventilation strategy. All dwelling units must use the same ventilation type moving forward. Now, in addition to that, the dwelling unit should comply with both requirements. Now, you'll see here that there's no longer an option to use exhaust ventilation in the dwelling units. That has been removed from our energy code. So what that leaves is either a supply ventilation or a balanced ventilation strategy. So no more exhaust, only supply or balanced systems. We're going to talk about the options within these two here once we get to the prescriptive requirement. But in addition to meeting those ventilation strategies, blower door compartmentalization, this is a test to ensure that the air transfer between dwelling units has been minimized. Now, this is now a mandatory requirement for all dwelling units, where prior to this code cycle going into effect, compartmentalization was required when using the exhaust ventilation strategy. So it was conditional upon a specific strategy of ventilation. Now it is required for all ventilation. So those spaces need to be tested to ensure that the air movement or transfer between those two dwelling units or multiple dwelling units is minimized there. Now moving over to additions and alterations, dwelling units can use any of those three options. So exhaust ventilation is allowed for additions or alterations when either required or voluntarily choosing to meet those requirements. All right. As I mentioned earlier, we're going to revisit these ventilation requirements and how they apply prescriptively. There is a major shift in those prescriptive requirements as well. All right. Now, based on the changes to the 2025 Energy Code, the mechanical ventilation for our common use areas have changed. The dwelling unit ventilation requirements has not changed. It's still roughly 0.3 CFM per square foot of space and 7.5 CFM per occupant. So that still establishes our ventilation requirements for dwelling units, whereas our common use spaces is getting an overhaul to the ventilation formula. So where any of our participants, mathematicians here, it doesn't necessarily mean that this is a hard calculation. It just means that we have an option here. We can either use the occupant-based equation, essentially multiplying 15 CFM times the number of expected occupants to that space, or the area-based equation, where it's taking a factor based on the conditioned floor area, the area of the space. So in this situation, the larger of the two would set the requirement. Now you'll notice that there is a new table or an updated table in section 160.2, table 160.2b, which establishes the minimum occupant load density and ventilation rates for multifamily common use areas. Now, if you're using the prescriptive approach and the virtual compliance assistant, these formulas are baked into the forms. So all you need to do is enter either the expected number of occupants or the areas, and the software or the form will do the work for you. All right, moving over to DHW or pipe insulation requirements. The 2025 code is stepping up some of these requirements to fully insulate those pipes. These measures include specific installation requirements, how to insulate this. So the picture that we're showing you here is not a good example of meeting those requirements, because all of those elbows, all of those unions, all of those intersections need to be insulated. The new requirements also specifies the location of the insulation within the mechanical room, the thickness of the insulation according to table 160.4a, and the protection to make sure that that insulation remains in place for the life cycle of that equipment and piping. All right, moving on to our dwelling units. For the 2022 code, we saw this change affect our single family buildings, where there were provisions to make ready for the future installation of a heat pump water heater. So in this situation, when a gas water heater is installed, the space needs to make provisions for the future installation of that heat pump water heater. That includes a designated space for that water heater, meeting a minimum size, width, depth, and height. Must contain a condensate drain line. The technology changing from a fossil fuel or gas water heater changing to a heat pump, where the heat pump is extracting heat out of the ambient air. The byproduct could be some water, so that needs to be drained away without the assistance of a pump. In addition to the location and the condensate drain line requirements, there's requirements for the future power for that appliance. So depending on where that designated space for the future heat pump water heater is, if it's within 3 feet of the installed water heater, then all that's needed is a dedicated 125 volt, 20 amp receptacle. That's a mandatory requirement currently, with an additional conductor wire. So that would make the circuit 240 volt capable, as long as it's labeled on both ends and that space in the breaker panel is reserved for the future installation of a double pole breaker for that 240 volt circuit. There are other requirements for ventilation. These are brand new requirements that apply to all dwelling units. We'll see here for the heat pump ready in dwelling units, you have to consider the makeup air for that heat pump. So as I mentioned earlier, heat pumps extract heat from ambient air, and it's either surrounding it or from the outside. So there are methods for achieving this outlined in 160.9E. So there are two options. Either the designated space for the future heat pump water heater has a minimum volume of 700 cubic feet, or that that space be ventilated either by a louvered or screened opening within the space to the adjacent larger space that's providing the makeup air, or that system can be ducted, meaning that it can be ducted either to the outside or to the other space, so the supply air as well as the exhaust air. Now, that duct is required to be insulated, needs to be insulated to R6 and sealed so that we don't have air leakage within that. So when these requirements also apply to central systems, when a gas or propane central DHW system is installed, essentially the same requirements apply. We need to reserve some space for the future installation of that central heat pump water heater. The ventilation needs to be either to the outside or to the indoors. If it's to the indoors, then that needs to identify the designated pathways for that makeup air and exhaust air to meet the minimum volume requirements. Got to have a condensate drain line, and you need to have the electric power to that space provided for and sized correctly for the future installation of that heat pump water heater. All right, jumping around once again to pool and spa requirements. We've had for decades requirements in our energy code to that regulate heated pools and spas. These requirements have been updated to include new options for complying with this, as well as the forms associated with meeting these requirements. So this applies to newly constructed heated pools or spas, or newly installed pools and spas, meaning that if a pool or spa is part of a new construction building project, or if a pool is installed with an existing building. So now there are 5 options here. I would say 4 of these are viable options. One may be a future option, depending on future technology coming out. But option number 1 would be to use a solar pool heating system. That'd be a solar thermal system. The requirement would set at least 60% of the surface. The collector needs to be at least 60% of the pool surface area, pool or spa surface area. That would be adequate to meet the pool heating requirements. Option 2 would be to install a heat pump pool heater, meaning that the primary heating system is sized to meet the requirements of reference joint appendices JA 16.3. So you can reference JA 16.3 for those requirements. And supplementary heaters can use an energy source, any energy source. That could be electric resistance, it could be a gas energy source, as long as they meet the control requirements associated with that supplementary heat. Third option there is to use a system that derives at least 60% of the annual heating energy from on-site renewable or recovered energy. That means a solar PV system is being used to provide the electricity for that solar system or the pool and spa heating system. Fourth option there, a combination of both pool heating systems and a heat pump pool heater with supplementary heating. So there are lots of different options to meet this. And the fifth one is basically anything that's determined by the executive director of the Energy Commission to use no more energy than what is listed above. So that's the caveat there for the future exception of other technologies. All right. In addition to meeting those different strategies for pool heaters with the supplementary heating, either electric backup or gas, if those are used or installed, you got to meet those control strategies. Essentially, they don't want the supplementary heating to be running continuously. There has to be a cutoff temperature when the heating, when the heat pump is higher than the cutoff temperature, and when the outdoor ambient is lower. So essentially, allowing the supplementary heating to come on only when it's needed to provide supplementary heat, and that the heat pump provide the heat to the pool heater when there's ambient outdoor temperature to support that. Typically, the cutoff temperature is 35 degrees in the outdoors, but you can refer to the joint appendices for that. All right, let's move on to our prescriptive requirements. Again, as I mentioned before, some of these measures have specific mandatory requirements and also have updated prescriptive requirements. So let me know if you have any questions as we're going through these and how that might interact or impact the mandatory requirements. All right, Dwayne says, does this mean a gas heater as the primary pool heating source is not an option? That's correct, Dwayne. If we go back to these requirements, this is all you can use and still meet the energy code. So solar thermal, a heat pump with supplementary heating, or if you have enough solar PV to use a electric source if 60% or more of that heating is from a renewable energy source. So yeah, that's exactly what it means, Dwayne. That's not uncommon with other features in our energy code or other requirements in our energy code. Prescriptively, in a lot of building types, we won't be able to use a gas space heating system. We haven't been able to use gas water heating systems for single family for at least a code cycle now. So that's the direction in which our energy code is heading. Carbon emissions reductions and building electrification is one of the primary focuses. All right, let's take a look at some of the prescriptive envelope requirements. Now, these are excerpts from Table 170.2a, so found in subchapter 11. So if you're following along in the code, you can see these. Now, we've highlighted in orange the effective change from the 2022 code. So you can see that most of the roof ceiling options Well, all of the insulation options for option B, that would be a ventilated attic with insulation at the ceiling, and in some climate zones, insulation below the roof deck. So none of those requirements have changed. What has changed here regarding our roof systems is the cool roof requirements. We've seen for certain climate zones, 10, 11, 13, and 15, we've seen an increased stringency in the aged solar reflectance. So that's one of the qualities of a cool roof, along with the thermal emittance. So these metrics, the higher the value, the better thermal characteristics of this particular feature of a cool roof. So the aged solar reflectance has increased. The thermal emittance of that product has remained the same. So now there's an optional metric using the solar reflective index, or SRI, to achieve your cool roof requirements, and those have increased too to reflect the increase in the aged solar reflectance. All right, moving a little bit further down the table 170.2a, you'll see option D. Now, option D is for wood-framed roofs, so, or non-attic roofs. I like that generic term, right? When we're referring to a non-attic roof, we're referring to a cathedral or rafter roof. So we've seen in some situations or some climate zones where the stringency of that aged solar reflectance for a low slope roof has been added to our energy code. So these areas in climate zones 2, 4, 6 through 8, and climate zone 12 previously had no requirement for a cool roof on a low sloped roof. Now, if you're wondering what a low slope roof is, a low slope roof is a roof that is less than a 2 and 12 pitch. Anything that is a 2 and 12 or greater would be a steep slope roof. So you can see that the requirements for cool roofs have not changed for steep slope, but we've added essentially nearly all the climate zones other than climate zones 1, 3, 5, and 16, which are moderate to cold climate zones in those areas where a cool roof would not be an advantage. So, all right. Moving down a little bit further down, table 170.2a, regarding our fenestration requirements. We've just seen a consolidation here of the fenestration requirements. Now, when I'm talking about fenestration, we're talking about vertical windows and skylights. So that's just a term that represents all of the translucent or areas, assemblies that will allow visible light and heat causing light to enter. So you'll see that the maximum U factor has been reduced in many of those climate zones. So once again, our energy code is getting more stringent here, reducing heat transfer through the fenestration products. All right, moving a little bit further down the list here, we've seen some updates to table 180.2b. Now, this table is applicable to alterations when altering existing fenestration in an existing building, either replacing fenestration or adding additional fenestration. So you can see that for curtain wall storefronts, they're in certain climate zones. Again, those moderate to cold climate zones, 1, 3, 5, and 16, really follows our single family requirements, meaning that in those specific climate zones, there are no longer solar heat gain or relative solar heat gain coefficient requirements. If you're applying prescriptively, any SHGC value of the window installed will comply in those 4 climate zones. In the remaining climate zones, there is a specified solar heat gain coefficient requirement. If you're complying prescriptively, you would need to meet that requirement or be lower than. Now, when you're using the performance approach, you can specify uh, uh, solar heat gain coefficients that are higher than the prescriptive requirements, but just keep in mind in those 4 specific climate zones, 1, 3, 5, and 16, um, that when you do increase the solar heat gain coefficient, you're going to see a benefit to the heating system uh, margins, meaning that if you allow more heat causing light in a colder climate zone to enter the building, that offsets some of the heating load and you get some savings. But just keep in mind, if you specify that on the CF1R and plan sets to achieve a much higher solar heat gain coefficient and the builder installs a lower heat gain coefficient, then technically that project needs to be reanalyzed to ensure that that lower SHGC window still complies. So that is my warning. I will stop talking about that now. We do have issues where consultants are exaggerating this and kind of cheating some of these requirements. So just want to put that out there. So we see this application of solar heat gain coefficients apply to all of our different fenestration types, AW class or architectural window class, as well as all other windows and doors. In addition, we've seen a minor improvement again for those manufactured windows and doors to achieve a lower U factor in certain climate zones. All right. Let me know if you have any questions. Pretty quiet in the chat window, so just plugging away here with our presentation. But if anything piques your interest or you need further explanation, I'd be happy to explain it for you. All right, moving on to our prescriptive requirements for mechanical systems. Cooling towers, the fan efficacy has been revised. In fact, the stringency of this code has been increased tremendously for these system types. So this is referring to the fan, the axial fan in open circuit cooling towers. These are for units serving condenser water loops for chilled water plants greater than 900 gallons per minute to have a minimum fan efficacy. So fan efficacy is watts per CFM of that fan. So the minimum rated fan efficacy has been increased. Formerly, most of these climate zones had a fan efficacy of 60, and that is, I'm sorry, I said watts per CFM. This is in gallons per minute per horsepower. So that means that this has gotten more stringent. Great. Dwayne, on your question, would gas heating for pools even be acceptable for supplemental heat? It is a form of supplemental heat, and the Energy Code just says that supplemental heating is allowed as long as the primary is a heat pump and that you meet the control requirements. So yes, you could use a dual fuel heat pump pool heater if they make such a thing. So I'm not aware of one on the market currently, but they do have dual fuel space conditioning systems at this point. All right, moving back to our mechanical system requirements. This is where I was talking about the differences between the mandatory requirements. Earlier, I was talking about the strategies for meeting our dwelling unit ventilation. The exhaust ventilation is no longer a strategy that's allowed. Mandatory requirements say either supply or balanced. Now, here's where our Energy Code says if you're complying prescriptively, you must install a balanced ventilation system with either an ERV, which is an energy recovery ventilator, or an HRV, which is a heat recovery ventilator. In this situation, this applies to individual ventilation requirements for a multifamily building in climate zones 1, 2, 4, and 11, 1, 2, 4, 11 through 14, and 16. So if your building is in one of those climate zones and you're using a strategy where an individual ventilation fan is serving a dwelling unit, then prescriptively you must install an HRV or ERV that has to have at least 60% sensible recovery efficiency, rated at 32 degrees Fahrenheit outdoor ambient, have a fan efficacy of 0.6 watts per CFM or less, and it does require field verification for accordance with the residential and non-residential appendices. Now, if we're talking about a multifamily building that's 3 stories or less, the ECC rater, formerly known as HERS rater, would be responsible for that verification. If it is 4 stories and more, it would be the installing contractor responsible for that field verification. Moving over to ventilation systems serving multiple dwelling units. Again, this is subject to our multifamily buildings 4-story and more in climate zones 1, 2, 4, 11 through 14, and 16. To be a heat recovery ventilator or energy recovery ventilator, have the same fan efficacy or sensible recovery efficiency of 0.67 or 67%. Meet the fan power requirements of section 170.2 C4A, and have a recovery bypass or control to directly economize with ventilation air based the outdoor. Essentially, that ventilation fan could also be used as a cooling fan according to the limits on table 170.2G. And of course, be field verified. In this case, it would be verified installation by the installing contractor. Good. So now keep in mind, you're still allowed to use supply ventilation, but you would only be allowed to use that if you demonstrate compliance using the performance approach. So that is important, and you will be incurring an energy penalty. So it may be more beneficial to meet the prescriptive requirement in many cases, so you don't, so you can avoid that penalty for other types. So this also still requires the compartmentalization testing, the blower door testing to ensure air transfer between those dwellings is minimized. All right. Now, for those ventilation systems serving multiple dwellings in our 3-story and less buildings, this only applies to buildings located in climate zones 5 through 10 and 15. When a heat pump space conditioning system is installed to meet the requirements for a mechanical system, a balanced ventilation system without an ERV or HRV shall be installed and have a fan efficacy of 0.4 watts per CFM or less. Again, this is going to set the baseline for compliance using the performance approach. So if you choose a supply ventilation strategy and not a balanced system, this will be a penalty. So again, you can avoid the penalty by installing a balanced ventilation system without an ERV when a central system is serving a low-rise multifamily building, 3 stories and less. All right, for those of you who've been around the energy code for a while, the term fault indicator display was a term used for an alternate way to comply with the refrigerant charge verification requirements. I often refer to these as the purple unicorns. They never existed. They've been in our energy code as an option for refrigerant charge for a couple decades. No one's ever invented one or brought one to market. So the Energy Commission decided to give up on that option and repurpose this term for HRVs and ERVs. So for all HRVs or ERVs systems installed serving individual dwelling units, they must have a fault indicator display. Essentially, this is an indicator to the occupant that the ERV or HRV has a fault. There might be an issue with airflow over that, and that system can't work efficiently. So it might be as simple as replacing a filter, or maybe having the system serviced by a technician. But this is enabled to the occupant to sense that there's a problem with the HRV or ERV system. Now, this also needs to be verified that that fault indicator display is working and functioning the way it was designed to function by an ECC rater. All right, moving on to some water heating requirements. So when water heaters are installed to serve individual dwelling units, it's a 1-to-1 ratio. So one water heater, one dwelling unit. That would be meeting this description here. There are two choices. Now you'll notice that the option to remove a gas or propane instantaneous water heater has been removed from the 2025 code. So again, this is a prescriptive requirement. It doesn't mean you can't use a gas or propane tankless water heater. It just means that you cannot comply prescriptively with one. So your choices are a single 240 volt heat pump water heater to be installed. And now those particular water heaters could be of any type as long as they meet the minimum federal and state efficiency requirements. Now, if that water heater is installed in climate zone 1 or climate zone 16, must be in conjunction with a compact hot water distribution basic credit, meaning that the ratio of distance to from the source to the kitchen sink to the master bedroom outlet into the furthest other hot water outlet cannot exceed the ratio of distance to floor area. In addition, climate zone 16 would also be required to use a drain water heat recovery system. That's just a simple heat transfer on the drain water from a shower or a tub to either be indirectly recirculated back to the water heater or to the outlet. So we're not directly transferring wastewater to potable water. This is an indirect transfer using a copper heat transfer. So if the dwelling unit has one bedroom or less, then you can use the 120 volt heat pump water heater. Essentially, in this picture that you're seeing, there are two elements. Both of those elements would be 240 volt elements. In the option for 120 volt, you would only have a single 120 volt element. So these systems are getting so efficient that they can run on a lower voltage. So, but just keep in mind the output or the flow of that is going to be less than a 240 volt unit. So the other option is install a single NEA rated tier 3. NEA is our Northwestern Energy Efficiency Alliance. It's the entity in which rates heat pump water heaters. That tier 3 requirement establishes minimum efficiency requirements that are above standard, as well as warranty, noise, other requirements that make this water heater last longer and produce more hot water. So now these typically are the units that are sold from the plumbing supply houses. So I'm not aware of too many folks selling heat pump water heaters that don't meet this requirement, but that is all based on what is being installed. So in climate, and again, with the NEA tier 3 heat pump water heater or higher at tier 4 in climate zone 16, install that drain water heat recovery system. So that is an option. So there are no prescriptive requirements for water heating in our common use areas. As long as that water heater meets the state and federal requirements, it can be installed. So, and meet our prescriptive requirements. Not so for the dwelling unit water heating. All right, for our central water heaters, those are situations when the water heater is serving more than one dwelling unit. It could serve more than one, or it could serve all the dwelling units within a multifamily building. That system type needs to be a heat pump near tier 2 or higher, or a single pass heat pump system, meaning that the entering ambient water temperature gets heated through a single pass through a heat pump and then distributed to the building, whereas a multi-pass system uses a staging of increasing the water temperature. So those are two different central DHW strategies, but the single pass system sets the prescriptive requirement as well as the standard design when using the performance approach. So you can use a gas or propane system served by solar thermal. So there's no change from the 2022 code. So you would still need to provide a percentage of annual thermal energy through the solar system if you're installing a gas or propane system. In addition to that, you would also need to meet the heat pump central water heater requirement ready if that was installed. We talked about the hot water piping mandatory requirements. There are new prescriptive requirements for that piping to be sized according to Appendix M of the California Plumbing Code. So Appendix M looks at the diameter of the pipe and the length so that in order to expedite getting water over a long distance, those pipes can be restricted down to a smaller diameter. So it is beneficial that those pipes be sized. Therefore, it created a new prescriptive requirement. Now, in addition to those requirements, recirculating systems, anytime the water heating system is serving 9 or more dwelling units, it must use a recirculating system. The change for 2025 is that the mechanical or digital thermostat master mixing valve controls be added to that distribution system. What this does is enables the water heater to increase the tank temperature, and the distributed water gets mixed with cold water to meet the call or demand for hot water. So this enables the water heater to work more efficiently and provide more hot water to serve the space. All right, another check your understanding question. Hopefully everyone's following along, and these are not too intrusive for you. But tell me what you think about this. What is a valid indoor air quality ventilation design configuration under the 2025 Energy Code for multifamily dwelling units? Can I use an exhaust fan? Can I use a supply fan? Can I use a balanced ventilation system using a combination of supply and exhaust? Can I use an exhaust fan system with blower door testing? Right. So I would say 2 of those. This is a select all that apply. 2 of those are correct answers. 2 of those are not correct answers. So I'm seeing everybody respond C. Yeah, absolutely. That is one of the options. Use a balanced ventilation system with a combination of both supply and exhaust. That's the definition there. So good. If you also said B, you would be absolutely correct. Thank you, Jody and David. Appreciate that. So just keep in mind, the mandatory requirements has excluded the use of exhaust fans in our multifamily dwelling units. So no longer is that a strategy. Must be either supply or balanced. So good. How about this? Which of these water heaters can be used prescriptively to serve a new dwelling unit for a 3-story multifamily building? Could it be a heat pump water heater, 50 gallons or less? Heat pump water heater of any size? A gas tankless water heater? Or an electric tankless water heater? So let me know what you think on these. David says A. Okay, a heat pump water heater, 50 gallons or less. I would agree with you, David. Anyone else? All right. Well, I think I found the exhaustion level to check your understanding questions. 2, that's the max, right? All right, so if you said A, you're correct. It's also B, heat pump water heater of any size. So what is no longer allowed is a gas tankless water heater, and electric tankless water heaters are not allowed prescriptively and have not been allowed prescriptively. So we've only seen an exception recently in our energy code for single family dwellings being 500 square feet or less. So now it doesn't mean you can't use them. It just means you would have to use the performance approach, but the ability or the reality of actually getting a project to comply with an electric tankless water heater pretty low these days. All right, let's move on to some lighting requirements. So we have both mandatory and prescriptive lighting requirements depending on what area of the building that we're looking at. So we're looking at the dwelling units. These are mandatory requirements, meaning that those requirements must be met. There are no trade-offs. You can't outperformance your way from being able to use low efficacy lighting. All lighting must be high efficacy, and there's new definitions and terms and exclusions from what is determined to be high efficacy these days. So now that's for the dwelling units, or any outdoor lighting switched within the dwelling unit would apply by and large with the same requirements as single family buildings. Now moving over to the common use areas, these more or less align with the non-residential requirements. So just kind of put you in the right mindset. So these requirements have both mandatory requirements for controls and prescriptive requirements for allowed lighting power. Now, one of the compliance options, prescriptive compliance options, has been removed. The tailored method, this was allowed for multifamily common use areas only. Again, the only way to comply with lighting within a dwelling unit would be meet the mandatory requirements, whereas those common use areas for determining the allowed lighting power under the 2022 code and earlier, we've had an option to use what's called the tailored method. This was a method that allowed additional lighting power for various tasks and display lighting. This was a different strategy than the area category method, and allowed a lot of flexibility. So this is no longer an option for common use areas of multifamily buildings or for non-residential buildings. Rather, the Energy Code decided to simplify by combining some of the requirements from the tailored method into the area category method to allow additional lighting power allowances for some of those common use areas where either display lighting is common or there is additional task lighting necessary for that space. So here are some of the examples. You can see we've just given you an excerpt from table 170.2M, and we've expanded the conference, multipurpose, and meeting area. Just understand that everything within that orange box has been added to the area category additional lighting power options. So it gets a lot more granular depending on the mounting height or the MH of that light. So for wall display, you can see, for example, you're allowed additional 2 watts per lineal foot of wall display. And depending on that wall mounting height, you can get various other additional lighting power options. And that is in addition to the general lighting allowance of 0.75 watts per square foot. So you can see how that can be used to provide additional lighting power for those spaces. All right, there are similar updates for various primary function areas within that common use area of a multifamily building. All right, we're going to move into some prescriptive requirements for PV systems and battery storage systems. Again, we've seen some changes here. Now, just as a level setting here, newly constructed multifamily buildings are subject to solar PV requirements and for all multifamily buildings. Now, we still separate those requirements based on the number of stories, 3-story and less, and 4-story and more. So those requirements are going to be in 2 different subsections within the code, 170.2 F and 170.2 G for the PV requirements. We'll look at those in just a moment. Whereas the battery storage requirements only apply to multifamily buildings 4-story and higher. That's the distinction there. It's a little table here might be helpful to remind you of when and where those requirements are and what applies based on the number of stories of the building. Now, for our 3-story and less multifamily buildings, the equation to determine what the minimum PV capacity is has not changed. What has been changed is we have a new formula for using the SARA method, or the solar access roof area method. So we've seen the option we've had in the previous code cycle by multiplying the SARA times 14 watts per square foot. This now applies to low sloped roofs. Again, low sloped roofs are those roofs with a pitch less than a 2 and 12. We also have new SARA multipliers for our steep slope roofs. Multiply that SARA, or the solar access roof area, times 18 watts per square foot. Now, out of these 3 options here, you get to use the smallest of those options. So either the equation method or the SARA method, whichever is less, will set the minimum prescriptive PV system sizing. Now, along with this change, the Energy Commission realized that the exception for the minimum capacity set at greater than 1.8 kW was a little bit low for a multifamily building. So they made this more in alignment with the non-residential requirements, meaning that now that exception applies if the minimum PV system size is less than 4 kilowatts DC, then no PV is required to install. So that is updated from the previous requirement of less than 1.8 kW. Now, just as a refresher, this is the equation, or the DC rating method. Some people call it this CFA method. Whatever you call it, this is the equation 170.2C, essentially using the conditioned floor area and the number of dwellings to establish what the minimum PV system size by using the adjustment factor tables based on the climate zone the project is located in. So there's no change to the table, no change to the equation. Just the fact that we have another option for the SARA method allows some flexibility within this option here. Now, just as to reiterate, this equation, very simple. This equation is used in the performance approach now. So no longer will the performance approach use a estimated annual energy usage. It will actually use equation C or the SARA method, whichever is less. If you enter the SARA, it will choose the lower of the 2. So moving on to our 4-story and more, the prescriptive requirement, again, no change to the equation. Equation 170.2D has stayed the same, but we also see the SARA options for a low slope and steep slope roof carry over to our high-rise multifamily buildings. So again, the smaller of the 2 options will set the minimum PV system size for a multifamily building that's 4-story and more. So we've taken the time to go through an example of the high-rise multifamily building equation. Again, we're considering the 2 strategies, either the CFA or DC rating method and the SARA method, where we have a sample building, 4 stories, climate zone 3, with a conditioned floor area of 100,000 square feet. We can easily do that math and determine that the minimum PV capacity or rating for that system is 182 kilowatts. If we use the SARA method for a steep slope roof, we would multiply that SARA, 25,000 square feet, times 18 watts per square foot, and we'd come up with a result of 450 kilowatts. Being that we get to choose the smaller of the 2, the minimum PV system size would be 182 kilowatts for this system. Now, keep in mind, these are prescriptive requirements, and if you're using the performance approach, you can trade away prescriptive requirements using the performance approach, meaning that it is feasible to reduce these PV system requirements by increasing the efficiency of the building. In some cases, these PV system requirements may be traded away. It's unlikely that they'll be traded away completely, but it is an option there. So again, the PV exceptions for our 3-story and fewer. This slide seems to be a little out of place, huh? Should have been a little bit earlier. We've already covered these, so that minimum PV system size exception was increased from 1.8 kW to 4 kW. Whereas our 4-story and more buildings, the PV exceptions, there was one exception that was changed. Previous code cycle, or the current code cycle in effect now, had an exception for projects that didn't have virtual net metering, meaning that the benefit of that solar couldn't be given to the occupant of that space if there was a single meter and those occupants weren't sub-metered. So the new option here is the program is provided to compensate PV generation through a virtual energy billing credit for occupants of non-residential and hotel motel tenant spaces to give or multifamily buildings to receive an energy bill benefit from netting the energy generation and consumption. So essentially providing the benefit of that the PV to the occupants. If that is not available, then solar PV is not required to install. All right, moving right along, just to have a few minutes left. We're at the tail end here. I want to cover the battery storage requirements. Just keep in mind that battery storage requirements only apply to high-rise residential buildings, 4-story and more, non-residential and hotel motel buildings. So there were some updates to the equations. One equation has been for our energy capacity has been overhauled. You can see that the equation in kilowatt hours multiplying the conditioned floor area times the adjustment factor B for the climate zone divided by 1,000 times the round trip efficiency or the capacity of the battery. So there's a different factor involved in this than was factored in for the 2022 code. So in addition to that, you can see our example here in our 4-story multifamily building, climate zone 3, that it would require 192.9 kilowatt hour energy capacity battery. In addition to that, the power capacity would also need to be factored in. We have that on the next slide. Now, there are some situations when the PV system is used, the PV system was sized according to the SARA method on portions of the building, and the other was using the conditioned floor area method. This is essentially an equation to do a weighted average between the two spaces to determine this. Again, if you're using the prescriptive approach, these equations are baked into the form, so you don't have to be that mathematician to figure out some of these, but it is automatically generated through the form. All right, here's the sample equation for the energy capacity. So both power capacity and energy capacity for batteries need to be provided. So this essentially says that using this weighted average for adjustment, that 192 kWh system would be reduced to 57.87 kW based on those two different strategies for determining the PV system size. Power capacity, very simple. Take the kWh rating for the battery requirement divided by 4. Again, that would determine our sample project here to have a 48.2 kW power capacity. So slight changes in these equations here. Right. No changes for the exceptions for batteries in our 4-story and more multifamily buildings. Those haven't changed from the 2022 code. All right, just about at the end here. I know Cassie has some wrap-up slides. I'm going to go ahead and go past our Check Your Understanding quiz because I think we all know that. And just share with you some of the answers to these Check Your Understanding questions. So one thing I want to cover before we get away here, if you want to reach out to any of our subject matter experts through Energy Code ACE, you're always welcome to submit a question. We respond quickly. In fact, if you want to get directly to me, best way to reach me is submit a question and make that question a residential building question. Those go directly to me. I respond with very comprehensive responses here. So anywhere where it says ask a question or there's a question mark on the website, you can click on that and submit a question to Energy Code ACE, and we will quickly respond to your questions. Cassie, back to you.
Yes, thank you so much, Brian. So I'm going to launch our evaluation poll while I just take over the screen and do our final slide. So thank you so much for attending, everyone. If you have any final questions for Brian, you can put them in the chat. Just so you know, the slides from this presentation and your ICC certification will be provided after completion of the evaluation poll, which is now up approximately 1 week from today. And as a reminder, you can also reach out to IREN at info@iren.gov if you have questions about upcoming classes or anything like that. And you can also always visit www.iren.gov to look at our upcoming trainings, sign up, check out our other resources. And as Grant mentioned earlier, you can also get our technical assistance there. So thank you very much, everyone. I will stop sharing my screen and we can have the floor open to Brian if there's any last minute questions. Otherwise, yeah, take the evaluation poll if you don't mind, and have a great day.
All right. Thank you, Cassie. I'll stick around for a minute or two. If anyone had any questions, anything specific to the material we covered or any other energy code related question, happy to provide some insight on that. Otherwise, if not, have a wonderful afternoon, everybody. And thank you for hanging out for the last hour and a half.
Thanks so much, Brian. We really appreciate you.
All right.